Okay, so we are going to go over the notes for the Pythagorean Theorem's algorithm. So we have here a right triangle. So the Pythagorean Theorem is special. It only is unique to right triangles. We're going to talk about the different parts of the right triangle. We have legs of the right triangle. Those are what are connected to or adjacent to the right angle. And then you have the one that's diagonal to the right angle. That's called the hypotenuse. This one diagonal, that's considered the hypotenuse. So we're going to go ahead and fill in our notes. The legs in a right triangle are always adjacent to the right angle. The hypotenuse is directly across from the right angle. The hypotenuse is always the longest side of the right triangle. The Pythagorean theorem is a squared plus b squared equals c squared. Use it to find the missing side length on a right triangle. So it does not work on an isosceles, an equilateral. It only works on a uniquely right triangle. So it says we're going to practice using the Pythagorean theorem on the following triangles to find the missing side lengths. Okay, so that's what we're going to do. And we're going to round the answers to the nearest tenth if it's not a whole number. So remember, we need to recognize what our legs are. Now our legs, it's important to know because those are going to be the a and the b value in the Pythagorean theorem. So we're going to write our formula out. So my legs are again adjacent to the right angle. So the two that are adjacent are here and here. So we're going to do our a and b. And the nice thing about legs is I can call this one a and b or b. So it doesn't matter which one you refer to as your a and b. The only one that actually matters in the Pythagorean theorem is the c value. The c value is your hypotenuse. And remember, your hypotenuse is the longest one that's diagonal and it's across from that right angle. So we're going to fill in our answers for the side length. So a we're going to call 12, b we're going to call 20, and then c is our unknown. So we're going to fill this into our formula. So a is 12, we're going to square that number. B is 20, so we're going to square that number. And c is our unknown, and we're going to find that value. So what we're basically doing is we're finding the area of these values. So 12 times 12 is 144. 20 times 20, which is 400, equals c squared. Now we're solving an equation, so we're going to combine like terms on the same side. So we got 144 plus 400. That gives us 544 equals c squared. Now I don't want to know what c squared is. We want to know the value of c. So to unsquare a value, you're going to do the inverse, which is to take the square root. And what you do to one side, you have to do to both. When you take the square root of c squared, you're finding that the value is c. And a side note, the reason for that is because c squared means c times c. So I can take a pair out of a square root, which becomes just simply c. Similar to the idea that the square root of 5 times 5, which came from the square root of 25, well, the square root of 25 is simply just 5 because you have a pair of 5s. So that's the idea behind why we can take the square root. And so we're going to take the square root of 544, which is not a perfect square. So I'm going to round to the answer to the nearest tenths place. So 23.3 feet. And that's my c value. And as you can see, that is the longest out of the three sides of the right triangle. All right, so we're going to do the same thing. We're going to identify which values they gave us and which value of the Pythagorean theorem, a, b, or c, that we're looking to find. So if you remember, our right angle is here. So the adjacent or next to the right angle are a and b. So we can call either one of them a or b. So I'm going to call 5 my a value, 15 my b value. And again, diagonal and across from the right angle is the value of c. So we're going to use our formula, a squared plus b squared equals c squared. And we're going to go ahead and fill in our values for the side lengths. So a side length is 5. So we're going to square that number. Our b value is 15, so we're going to square that value. and our unknown is c, and we're going to have the square of that value. So we got 5 squared, which is 25, 15 squared, which is 225, and our unknown is c squared. Again, we're going to combine our like terms on the same side. So 25 plus 225 is 250. And again, that's our c squared. So that's the area of c. So we want to find the inverse, which is to take the square root. So we can just isolate c. And again, that's not a perfect square, so we're going to round to the nearest tenths place. That gives us 15.8 miles. Okay. All right, our next question. We're looking again to see which values they gave us on the right triangle. So we have our right angle here. So we're looking for the legs of the right triangle. So we have 30, which is one of our values. And then we have another leg, but our other leg is an unknown value. So we're going to either use that as our A value or our B value. So I'm going to call my A value the unknown, because my B sometimes can look like a 6. And then this time they gave us the C value, which is 50. So we're going to go ahead and fill in our formula. A squared plus B squared equals C squared. That's the Pythagorean theorem. Again, only works for right triangles. And we're going to fill in our values. So A, I'm considering my unknown this time. B, which is 30, square it. And C, which this time they gave us, which is 50 squared. So we're going to go ahead and start to solve this. I don't know A squared yet, so I'm going to leave that there. 30 squared is 30 times 30, and 30 times 30 is 900. And 50 squared, 50 times 50 is 2,500. So if you notice this time, I have an equal sign, but I have my like terms on the opposite side. So kind of think of this like you're solving an equation. So if I want to move this like term to the other like term, I do the inverse to move over to the opposite side, which is subtracting 900. So that's 0, because 900 minus 900 is 0. So we bring down what's left, A squared. And then we find the 2,500 minus 900 is 1,600. Again, we still have to find A, not A squared. So we're going to do that square root, which is the inverse of squaring. Square root of A squared is A. And then the square root of 1,600 is 40. And that would be yards. Okay, and then we have our next one. So again, we're looking for which values did they give us. So we always start with our right angle. So our right angle is here. So that's the 90-degree angle. And remember, adjacent to that or next to are the A and B values. Our diagonal, again, is our C value. So this is my C value. And then I either decide if this is going to be A or B, which one, it doesn't really matter. Again, I like my A's to be the unknown, so I'm going to use B for the value of 10. So I'm going to write my formula, A squared plus B squared equals C squared. And we're going to go ahead and start to solve. So A is my unknown, so I leave that there. B, which is, we said, 10, so I'm going to put 10 squared. And again, C is 26 squared. So we're going to go ahead and simplify this a little further down. So A squared, we still don't know what that is, but I do know 10 squared, or 10 times 10 is 100. And 26 squared, which is 26 times 26, is 676. Again, I need to move this to the other side of the equal sign, so I need to do an inverse operation. So we're going to subtract to make this a 0 pair. So my 0 pair is now taken care of. A squared still left. And on the right side, now I have 576. So I'm ready to find just A. So I take the square root on both sides, because you have to do what's one side to the other. So now we're left with A. And then we take the square root of 576, which is just simply 24. And this is centimeters.